Okay, so as we do with margin of errors, I want you to think of this problem once more. Okay, so from this particular problem, remember we're taking a survey of teens with the question of what do you think humans will be able to live on the moon? We're focusing on the year 2100. 48% of teens said that, hey, yeah, around that time we're going to be, living on the moon. But for this problem, it says there is an error of plus or minus 3%. There has to be something more than just 48%. Reasons because of this. First of all, as human, are we perfect?
No.
We are not perfect. Because we are not perfect, that's why we tend to make error, right? And sometimes a little error is actually acceptable in the real world. Is that true? I mean, for me, for example, if you're a driver, you think you're always driving straight all the time? Is it possible to drive straight? Even if you can, maybe your car won't allow you to allow you to drive straight because maybe the alignment is off, right? So sometimes even when you keep your wheel straight, your car will still lean left or lean right because of the misalignment. That could be true. So what I'm trying to get you to understand here is that nothing in this world is perfect. No one is perfect. And so therefore, for example, imagine if you're in the manufacturing business producing basketballs. Do you think that every ball that you produce will be the same shapes and size? I mean, yeah, maybe on the outside it looks round. It's about the same size. But if you have to measure it, every single ball using a precise instrument to measure, trust me, not every single ball is the same size. Maybe it's a little bit off. It's just so little that you can't even spot it with your naked eye. But it's still off somehow. With that slightly off right there, that's what we call acceptable margin of errors. But what we really want to have is a small margin of error so that we can still maintain some accuracy in life, right? Okay, here's another good example that I want to bring up. For example, you've heard of the election from last year, right? Every time the news reports something about people voting, oh yeah, 45% will vote for this candidate while 36% will vote for the other, but they don't just report it as 45 of this, 36 of that. Down below, if you watch closely enough, they also have something, oh yeah, there's a plus minus 4% or 5% of error. So what does that mean? Well, once again, because of that imperfection, we tend to make that error. And so even though I say, oh yeah, 45% will vote for this candidate, it doesn't mean exactly 45%. That's why we have to introduce the margin of error. Simply means, in this case, for example, 48% of students will actually voted that in the year 2100 we will live on the moon. Not true, not exactly 48%, because the margin of error tells us that it's plus minus 3%. So that means we can either have exactly 48% or it can all the way goes up to all the way to what percentage? 51%, very good. Or it could sway the other way to all the way what percentage? 45%. And that guy is what we call the margin of error. You see it? You have a good idea on that? Okay. Now, with this margin of error in mind, a plus minus, in mathematics we have a way to represent that, and that is called the absolute value. Have you heard of that term before? Yes. Good, so at least you have heard of it. So right now, guys, I'm going to go ahead and get right into absolute value. We're going to get back to this when we have a clear idea of what the absolute value is. So let's take a look. Let's start with something very simple. First of all, when I say absolute value, I hope you immediately think of this symbol. Is that true? We use that to represent absolute value. And that anything, okay, can you tell me, what does absolute value do to a number? Or any value? Yes?
It tells numbers bases away from zero.
Okay.
They are positive.
Okay, so let's just be more specific than that. In a sense, you are right, and you're telling what is it?
They are positive.
Make what?
They are positive.
They are positive. Okay, so good. So it tells distance. It tells that everything's positive. Okay, good, because distance is measured in positive which is great. So technically, to make it short for you, any value that's in this side, this absolute value sign, after taking the absolute value sign, will always turn positive. Okay? Always. So imagine if I say, what is the absolute value of 5? 5. Very good. What is the absolute value of negative 5? 5. Reason for that is because if you put this on a number line, here's a 0, here's a 5, here's a negative 5. I know we have two different sides. But if I ask you to take a ruler and measure the distance from 0 to 5 and 0 to negative 5, you will always say what? 5. You realize that? You would never say, oh yeah, the distance from 0 to 5 here is 5, and the distance from 0 to negative 5 is negative 5. No. You will just say still 5. Is that true? So when we talk about distance, it is represented as a positive as well. Okay? An absolute value will do that for you. Okay, questions so far? So when I talk about introduce absolute value, I expect to have two values, right? Because either one will still maintain its positiveness when you apply the absolute value. Check this out. So pretend now that I have the following. What if I have the absolute value of x and I'm forcing this to make it equal to 7? What can x take on to make it true?
7.
Thank you. So you said x, first of all, can take on a 7 because when you plug the 7 back into x, it's still going to be 7 because absolute value of 7 is still 7, right? Makes sense? And you said that on the other side, x can also take on a negative 7 because a negative 7 plugged into here will still become a positive 7 when you apply the absolute value sign. Does it make sense? So therefore, x can either be a positive or a negative 7. Two values as an answer. Any questions so far? Okay. Let's make it a bit more difficult. What if I have this? I have some value, take away 3, absolute value of that, will give me 8. Okay, so think for a moment before you say anything out. What do you think that value can be to make this true? Raise your hand, please. Yes. You said 5. Oh, think about this. 5 take away 3 is going to give you 8?
Oh no.
No. Oh, okay, so what do you think that value is going to have to be? Yeah. 11. Okay. 11 because 11 minus 3 is 8. Absolute value of 8 is 8. So it's true, right? What else can it be?
Negative 11.
Okay, wait. Let's say it again. Before you say that, try to mentally plug it into the equation yourself and see if it's true. When you say negative 11 minus 3 is what? Negative 14. You know it won't ever.
5.
What is it?
Negative 5.
Ah, negative 5. Let's see. Negative 5 minus 3 is?
Negative 8.
Negative 8. But we know that the absolute value of negative 8 is?
8.
Positive 8. So therefore, they're equal, right? So therefore, x can either be 11 or negative 5. Questions so far? Okay, next step I want you to do, I want you to graph this on a number line. Because this is an equal equation, it's an equation, I just want you to go ahead and plot the points. Here is 0, 1, 2, 3, 4, negative 5 is right there. That's my first solution. 11 is on the right hand side, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just do it, okay? Don't ask me why, but just do it for now. And I'm going to do a couple more problems, and I'm going to ask you to see if you spot any patterns, okay? Watch what happened. I'm just going to do it. Watch. From negative 5 to 11, I noticed that we have a total of 16 intervals. Is that true? Because this is 5, and that's 11 more, so that's 16.
Mm-hmm.
And then I'm going to go ahead and split that half, which is 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So that means it's right here. Is that? What did I just do? What did I just find? Find the midpoint. The midpoint happens to be at 3. So that means the distance from here to here is 8. The distance from here to here is 8. Just do that for me for no reason right now. You'll see in a minute. Or if you see a pattern already, good for you. But if you don't worry. You will see it soon enough.
I can't do those curly brace things.
Oh, you don't like that?
It's so sick.
I can't do it.
Oh, don't worry about it. Just do what you can. Okay? So notice every time I do the equation, I plot the 2 points, find the midpoint, find the distance between, and find the midpoint. Well, yeah, and then graph it, basically. Okay? Soon enough, you'll see something. Okay, got it? All right. I'm just gonna go ahead and zoom this, make it smaller, save it. I'm just gonna put it aside for now because I'm gonna use it later. Okay, next problem. So I have another one. What can x be to make this true? -6, you said. Let's try. Oh, you said -6?
Yeah.
Okay. -6 plus 4 is -2. Absolute value will make it 2, so it's true. Good. So that works. What else? What else can make this true? -2. Very good. Because -2 plus 4 is +2, right? And you know absolute value of +2 is still 2. Works pretty well. So I'm going to go ahead and do the same thing again. I'm going to put it on my number line. I'm going to go ahead and find the -2. Well, maybe I can adjust it a little bit. Here's a 0, -1, -2, 3, 4, 5, -6. Here's -6, here's -2. Oh, this is easy to spot. Right there's my midpoint, isn't it? Is that true? Or you can just quickly count up, oh yeah, this is 4, so half of 4 is 2, so 2 both ways. So that means my midpoint is at -4. Notice the distance from here and the distance from here is 2 each. Makes sense. Okay. All right. Have you seen anything yet? Okay, well, let me just go and do something side-by-side comparison, perhaps. Okay, I'm going to take this and place it over here. Place it over here. What do you see? Do you see any pattern there? Oh, okay. Well, say, come on. One thing at a time. What do you see?
The opposite of.
Do you see this 8 appearing somewhere in the equation? Ah, interesting. Do you see the 2 appearing somewhere in the equation?
Yeah.
Ah. Do you see this, what I circle, appearing somewhere in the equation? No?
Yeah, but it's the opposite.
Ah, okay. Oh, interesting. Opposite, opposite. Yes. Yes.
It's like the x minus the midpoint equals the distance away from
Great. Wouldn't you say that this is the margin of error, plus minus, in a sense, both ways? Isn't this your margin of error? So do you agree that your general equation of this would be, this is the midpoint, isn't it?
Yeah.
This outside is your margin of error. And basically, x take away the midpoint. Whatever midpoint is, you take the opposite of that. Is that true? If it's a positive midpoint, it would become a negative. If it's a negative midpoint, it would become a positive. So, technically speaking, if I just give you a graph with the 2 points like that and ask you to come up with your own absolute value equation, can you do it?
Yes.
Following the pattern, you can, right? So let's try that. See if you can actually get it. Maybe I don't want to erase it after all. Maybe I do. Let's see. Okay, watch this. So imagine if I have the following. Here is 1, 2, 3, 4, 5. Do we have to count? Sure, why not? Here's one. Here's another one. Can you quickly tell me what your equation will be for that one?
Yes.
What do you have to find?
Midpoint.
Midpoint. Where's the midpoint going to be?
1.
Is it 1 or 2?
1.
Think about it. Midpoint means it has to have equal distance in between, right? Is it 1 or 2? Okay, 1. So from here to here is what? What's the distance from 1 to -3?
4.
4. It has to be equal, right? So is it 4 also?
Yes.
Yes, it is. There. So, what will your equation be?
X
X
minus 1
4
equals
X minus 4
4.
X minus 5
Absolute value.
equals 4.
Good. Remember margin errors, right? Equal distance, 4, 4. Okay, see how easy that is? Okay. So clearly, you can see that you can actually get from one form back to the other. Either from equation to graph, or graph back to an equation.
How do you know if it's going to be subtracted or addition?
Didn't we just say that it's always going to be opposite of what you see?
Oh, yeah.
If this is a negative, if your midpoint is a negative, guess what this is going to be?
Positive.
Positive. See it?
So then it'll be addition?
Huh?
So then it'll be addition? If it's positive?
No.
Okay, Fernando. The reason this is a negative, like I said, is it a positive or opposite of 1? Depending on where your midpoint is going to be, it's the opposite of what you see.
So if it's like at -1, then that would be 1?
Yes, positive 1. Okay? And if it's at 5, then it's going to be -5. Is it? Okay? If your midpoint is at that location. Okay. So we clear this, right? Very good. Now let's actually make it a bit harder for you.
Yes.
You always make it hard.
Of course, of course. Okay. Here's a question. I have 2 times x plus 5 inside the absolute value equals to 7. What can x be to make this true?
1.
Okay, that's okay. Shh. Notice I'm setting this aside. 1.
That's a negative. Never mind.
Will that work?
Yes.
Yeah, because 1 times 2 is 2, 2 plus 5 is 7, absolute value of 7 is still 7, so 7 equals to 7. Perfect, good. What else can you be?
Negative 1.
Wait, okay. I love how he answered -1. He thought it's always going to be opposite of that. Now, let's try. If you plug in -1 into here, -1 times 2 is? -2 plus 5? Is
Never
it,
mind.
is it even close to 7? No, it's not, right? So, what do you think the other x going to be to make it -6, you said? -6 times 2 is? -12, -12 plus 5? -7. Absolute value of -7 is? Ah. So -6 actually works, right? But the goal is this. Like, wait, do we have to guess like this all the time?
Yes.
Well, the answer is no. Let me show you a technique to do this. And this technique is called making a Martian technique. It's green. Watch this. Do we agree that we want to make this thing inside equals to 7?
Yes.
Okay,
Yeah.
so I want to make this thing inside equals to 7. Agree? Yes? Because we know that the absolute value of 7 is still a 7. But we also know that we can still make it a -7 and still turn it back to a positive. Why?
Because the absolute.
Very good. So is it true that on the flip side of that, we can still force it to become -7? Is that true? Is that correct?
Yes.
We can force this whole thing inside to equal to -7 and then put an absolute value on it, and it's still going to turn to a positive 7. So it's still going to be true. So now we have the 2 ears for the R Martians. Let's eat 1 ear. So first here, I said, oh yeah, I want to force this to make it 7, so I'm going to have 2x plus 5 equals to 7. Watch what happened. So this is 1 at the left ear. Over here is the right ear. 2x plus 5 equals to what? 7, right? The 2 ears right there. Let's solve. Watch what happened. -5. We got 2x equals 2. 2 divided by 2. X is 1.
Whoa.
Right there. Watch the other one.
Exciting.
You subtract 5 both sides. You got 2x equals 2. -12, right?
Yes.
Divided by 2. X is?
-6.
There it is.
Whoa.
So no guessing involved. We get straight to the answers. You see it? Any question there? Okay. You see how that works, right? Let's try one more. Don't worry. But remember what I'm telling you right now. For this to work, the margin has to be by itself on one side, meaning the absolute value is the only thing that you see on one side. If there's anything in the front or in the rear, it won't work. You've got to get rid of those first. So here's an example of that. Pretend that I have the following. Okay? Pretend I have this particular problem right here. Tell me, can we start drawing the margin yet?
No.
Not yet, because of the 2.
Yeah.
Okay? We have to make sure we clear everything out before we make our margin. In this case, how do we get rid of this 2?
Distribute.
Okay, you might want to say that. Very good. Here's the thing.
Those aren't parentheses.
Absolute value signs are not parentheses. Very good. So because they are not parentheses, you cannot distribute either. You cannot touch anything inside of the absolute value sign. So you have to get rid of 2. How do we get rid of 2?
Subtract.
Okay, you say subtract. But think about this.
Divide.
Even though you cannot touch anything, but technically speaking, 2 is attached to this by multiplication, isn't it?
Yeah.
So therefore, to get rid of 2, we have to undo that by
Divide.
dividing. So I divide 2 both sides. Now, this is what you will see. Is that correct?
Yeah.
Yes?
Yeah.
I'm just dividing 2 both sides, getting rid of 2 outside. Right? Remember I told you we cannot distribute because this is not parentheses. So we have to get rid of it somehow. Well, in this case, it's linked up by multiplication, so I divide both sides. Now I can start my margin because I have absolute value by itself. Here we go. I want to force this to equal to what? 4 or negative 4. Very good. You see how that works? Because look, I have to force this to equal to 4 or negative 4 because either way it will turn to a 4 due to the absolute values side. Okay? So now I can start digesting each ear. Watch what happens. X plus 5 equals to 4. That's my first ear, right? Solve it. What do you get? Negative 1. So subtracting 5 both sides. So x is negative 1. Over here, I'm digesting the other ear. X plus 5 equals to negative 4. So I subtract the 5 both sides. X is negative 9. Okay, you see that?
I knew it this whole time.
Okay, now, let's graph it to show you. 2, 3, 4, 5, 6, 7, 8, 9. Negative 1's right there. Here's negative 1. Here's negative 9. And
Well, you're fast at making those.
okay, you see that right there? How it resembles everything that I talked to you before? Look at the negative 5, opposite. Look at your margin of error, 4. See that? How it all fits into the equation? Okay. Any question on that? Yeah? Are we clear?
Yes.
Okay. So we have that case. Let's see if you can actually get this. What if now I have that? Can I make my margin?
No.
No. How do I get rid of what I need to get rid of?
Subtract it.
Subtract it. Very good. Subtract the 6. So I would have x minus 4 equals to negative 4. Now my question is, can I make my margin?
No. Yes.
Yes or no?
Yes.
Yes.
Okay,
Oh,
yeah.
no, because it has to be positive.
Ah, interesting. What did you see?
It's a negative.
I see X
Very
minus
good.
4.
Notice that the absolute value sign right here. Absolute value will make everything inside it positive, right?
Mhm.
Can a positive ever equals to a negative answer? So you know that this will never be true, right? So if it's not going to be true, don't waste your time trying to solve because it won't work anyway. There's no value here. Subtracting 4, take the absolute value, will make it a negative again, ever. Therefore, just stop, say no solution. We're done with that. Is that clear?
Yeah.
So watch the problem carefully before you make your final decision whether or not to pursue it all the way and solve it. If
Can't
it's like
turn it
that,
into a positive?
Huh?
Can't turn it into a positive?
this, it's
Or
given
divide
like
it by
that, you
negative
can't.
one.
Unless there's like a negative 1 out here, then you divide both sides and turn it positives. So that's another way to say it too, is that don't always assume that because it's a negative on this side, it won't be able to solve. Think of this too. If you get rid of some number over here and make it positive on the other side, it's still solvable. Okay, in this case, for example, I can divide both by negative 1, and now, notice, I can still solve the problem. See, you see how that works? Alright, so watch the problem carefully as you solve. Alright, the last part to this that I want to share with you is graphing. I'm telling you right now that graphing is coming back in a big way. You need to make sure you remember how to graph. The last time we learned how to graph, what did we graph? Okay, so we have to do with slope, lines, basically, y-intercept, x-intercepts, things like that. Okay, let's review that for a moment. Pretend I have this right here. Do you recognize this? What's this called?
F of X.
Function notation, fx. Let's say I have the following. X plus 3. Okay? Clearly, this is a linear function. When I say graph a function, it's not going to be a number line, guys. It's going to be on the x and y axis. It's a function, okay? So, for those who remember how to graph using the slope-intercept format, it's good. Graph it. Here's the y-intercept at 3. Slope tells you to go where?
1.
I know, 1 what? One up?
One right.
1 right. Rise over run. Remember? Rise over run. I'll remind you right now. Rise over run. For those who actually remember how to do that, let's say you don't remember. What can we do? What's the other way to do it without remembering how to graph using the slope and intercept? Okay, a table. Thank you. Here we go. Let me show you how to create a table again. Here's the x. Here's the x plus 3. That will give you the y. You put the x and y together. That will give you your point. Remember the 4-column table? There it is. Coming back to you. So let's pick a couple of points. Let's say I'm going to pick
1.
-6, -2, 0, 2, and 6. Fair enough?
Yeah.
Okay. So let's solve. I plug in this -6 into x, I add 3. I plug in -2 into x, I add 3. I plug 0 into x, I add 3. 2, add 3. 6, add 3. Questions so far on what I just did? Just substituting, really. And then I solve. -6 plus 3? -3. -2 plus 3? 1? Okay. Next, 3? 5? 9. So I'm putting these together. I have -6, -3, -2, 1, 0, 3, 2, 5, 6, 9. Yes? And then I plot them. So this is my graph. I hope I have room. So it's going to be -1, 2, 3, 4, 5, -6, and -3 is right down here. I have -2 and 1, which is way up here. 0, 3, right here. 2, 5, right here. And 3, 4, 5, 6. 6, 9 is right up here. So I connect these. I will see a linear line, straight line. Okay, recall that? So, at least you can still graph a line using a table. Is that true? Okay, but you're probably going to ask me, well, so what does that have to do with what we're learning today? How's that going to help us? Well, think about this. We just learned how to do, okay, yeah, Jim, you have a question? No, please, what is it? Did I do something wrong? Okay. So how's that going to help us with today's lesson? Today we just learned how to do with absolute value, right? So instead of having just a linear function, watch what happens. If I put this in here, what will this become? What do you think you're going to call this now? What is it?
Absolute value.
Yeah, absolute value function. I just turn it into an absolute value function. But what is the effect of putting the absolute value sign around x plus 3? What will happen now?
No more negative.
No more negative. So that means, you notice how you got the negative over here as your answers? What will happen to that negative? It will turn to a positive. What will happen to the positive though? Will that change?
No.
No. So positive will stay the same. Negative will now turn into a positive. You see that? So how will that affect our graph? What point will be changed?
The bottom
The
one.
bottom one, because we don't have negative anymore. Is that true? So therefore, at that -6, -3, now it becomes a -6 and +3. So watch what happened. Here's -6. +3 is actually way up here. So our graph has taken a different turn. All of a sudden, there's no more negative down here. The graph now steers back up like that. What shape do you see?
B.
A V shape. So, absolute value function, expect to see a V-shaped graph. That's how you know you've got it correct. If you graph an absolute value function and you don't see a V coming out of it, something is wrong. You're not evaluating it correctly. Expect to see either a upward facing V or a downward facing V. But it has to be a V-shaped graph, not a straight line anymore. Well, yeah, but it has to be a V-shaped graph. Okay? So you don't see your V yet, that means you have not plotted enough points. You got to want to kind of spread out your points a little bit to see the whole picture. Okay? And this is the last step that I wanted to show you. Be able to graph an absolute value function, create your table, just graph it normally. Okay, any questions so far? Okay, good.